the 1, 4, 6, 4, 1,
Yeah.
that, and then like how do you continue after that for the rest? Like for 7, 8, 9.
Oh, it's because it's a higher power.
Yeah.
Ah, so you need Pascal's triangle up to number 7.
Then 8, 9, and
Yeah.
all of that.
Yeah, so to make the
Oh.
triangle.
So the highest they can give us is just 9?
No,
Or
no.
we
For
need to do it?
Pascal's triangle in the exam, the highest power that will be maximum 5.
Okay.
Yeah. If it's any higher than that in the exam, they'll ask you to use the C function on the calculator,
Okay.
the NCR button. You know the one, yeah. So Pascal is really only up to 5 for the exam. So, yeah, it's not really a necessary thing to do the triangle up to 7, because that means they would have to give you lots of marks to make the triangle up to 7. It's because it'll take time. So, you don't feel like we need to do this one now?
If it's not in the exam.
No. I mean, it's not impossible. It'll just take a long time to get up to number 7 on the triangle, you know. Like, how big is the triangle you have in your book? What row?
Just 5.
You went up to 5?
Yeah.
That's plenty then. That's plenty. And you know how to make 6 if you needed to.
Yeah, you just expand.
Yeah. Okay, so what else will we look at now first?
The reminder theorem.
Yeah, which page is that now? What page number?
22.
Yeah, which question?
5G.
5G. Yes. We'll do that one, yeah?
Okay.
Yeah. 5G on page 22. Let's have a look. Yeah, amna.
Yeah.
Like AM or AN?
AMNA.
AMN?
A.
A.
Yeah.
Okay, alright.
Call me Simba for a week.
Yeah, Simba. I like Simba more.
Call me Simba. This is Simba.
You know Simba, don't you? Yeah. Close enough. Right, let's have a look here. So, we have px cubed plus 73x squared plus 82x plus q. And when I divide that by x plus 3, and when I divide it by x plus 1, I get a remainder firstly of 150, and a remainder secondly here of minus 88. Okay, so if you just want to write that bit down before we continue, we'll take our time. This is an important example, okay, because these types of questions I see a lot in the exam, this remainder theorem. The only difference between section A and section B is this. In section B, the questions typically have 2 constants defined, P and Q, whereas in section A of the exam, it's usually only 1 constant. That's how they differ. And I think most exam papers have this question on it. It's either in section A or in section B, so like it is an important one. So we'll make sure we're all happy with this. Okay. So Amna, what do you think we should do first, if you have any idea?
We have to factorize it.
Factorize this guy? Is that what you're saying? Like factorize which thing?
The 2 brackets.
Yes, but which thing should I factorize? What do you think? Like, do you mean like to factorize this guy? Or?
Yeah.
You don't sound sure. But that's okay, I just wanted to see if you had an idea. That's okay. Abir, do you have an idea?
You substitute x equal to minus 3 in that equation.
Yeah. Here you change this into x equals minus 3 and x equals minus 1. Yeah. Is that what you meant, or you were? Yeah. So not factorize. That's not the word. Yeah. Here's a good English question now. What verb could I use to describe what I did there?
Solve.
Solve you can use for everything, and simplify. Anything else? It doesn't have to be a mathematical verb. What about a verb like convert, or just make, or even just find x. That would be that would do it then. Okay. Anyway, let's see, Alfreda, do you know what happens next? What we need to use next? Or Abir just suggested we change this into x equals 3 and x equals minus 1. So do you know what happens next? Substitute. Good. Now let's do the minus 3 one in here first. You have your calculator, Siba? Yeah. So we might need the calculator now. So I get P. Well, since this is your question, you can tell me what to write down. So this is P, and what do I write next? I'm substituting in the...
P bracket minus 3 cube.
Good, yeah.
Plus 73.
Yeah.
Bracket minus 3 squared.
Good.
Plus 82. Bracket minus 3. Plus q, yeah.
Good. And here's the key thing now. What does this equal?
30.
No. There's a number here.
0.
Not 0. 150.
Oh, we have to remind us 150.
Yeah. What's that called? What are we using here? We're using remainder theorem. Or T, using remainder theorem. Okay. Right, we'll have to calculate now. This will be minus 27p. Good gracious, what's this? Yeah? 411, okay.
It's both of them.
Oh, you put these two together, thank you. So together that makes 411 plus q equals 150. Siba, what will I do next now?
Do the same for x equals minus 1.
Yeah, do the same for minus 1. Maybe just before I do that, is there anything I can clean up here?
Yeah, minus 27 becomes plus 2.
I could change the sign. I'm going to leave the P and the Q on the left. So tell me what I need to move here.
150 minus...
Yeah, that's it. Yeah, okay, yeah. So what is that now?
Minus 261.
Minus 261? Okay. Right, now, you were saying what to do after this?
Yeah, put it instead of minus 3, minus 1.
Yeah, okay. So, maybe, Abir, you can tell me what I should write down next. So I'll have P...
You put both of them together?
Oh yeah, but what happens when I put in minus 1? So, P minus 1 cubed, yeah? What's the next one?
Plus 73
Yeah.
minus 1 squared.
Yeah.
82 into minus 1.
Yeah.
Plus q equals to minus 88. Yeah.
You were educated in a British system.
No.
What system?
Indian CBSE.
Oh yeah, British. England, you said.
No, I said India.
Oh, India. Oh, so would it be right to say that there's a British influence on this style? Because your choice of words are what they've used in the UK. So you just said here, into.
Yeah, it depends on our teachers.
Okay.
Say into, yeah.
This is British. This will confuse people here. Because into doesn't mean multiply, it means divide. So if an Irish speaker were said to you 5 into 10, that's not 50. It's 2. Yeah. So I'm only telling you this because when you're talking to people in school or you there might be confusion on the into. Yeah. I just think it's interesting how it can have the exact opposite meaning. It's like literally the opposite. Okay, so what do we get here? This is minus p, and then
q equals to minus 89.
Oh, thank you. So you've grouped it all together.
We did this like last Friday.
Oh, good. Okay. Well, that's good. So everybody should be experts now with this one. Okay. So, Alfreda, what should I do next now? I have 2 equations we just arrived at. I'll call this one A and this one B. So what do you think?
I was thinking of elimination.
Yeah, elimination, yeah. Which one to eliminate? Which letter to kill?
First thing is to put them together.
Well, first thing, let's write them together, it'll be helpful. minus 27p plus q equals minus 261, and minus p plus q equals minus 79.
Cancel q, because q is
By adding or subtracting?
subtract.
Good. Yeah. So that's minus 26p equals, oh goodness, what's that? Minus 100 and...
182 minus 182.
Good, okay, so we're nearly finished now. Amna, what should I do next?
Substitute the
Before substitute, before one little thing to do before that. I'm here.
divide by
Very good, yeah.
25.
Minus 26. So what's that? 7? And now what were you saying? I think this is the next thing.
And then we'll substitute the q. We'll choose an equation and then we'll substitute.
Oh yeah, sorry, I shouldn't tell you. Which one to choose?
The second one.
The second one, good, yeah. Why did you change your mind and pick the second one?
Because it's more simple.
It is, isn't it? Yeah.
Yeah.
So you have minus p plus q equals minus 79. So you get p equals minus 79 plus 7. What's that now? Minus 79 plus 7. Minus 72. Okay, so I have my p here, and then where did I put the q? Here's the q here. Okay. Now you really need to make sure you can do these questions well, because they're very, very typical exam questions. This one here. Is this one okay? Yeah? Good, good, good. Okay, so what will we have a look at next now?
So page 32, the second one, the P and then R.
32.
Yes.
Yep. Which question? Number 2?
Yeah.
Number 2, which part would you like?
And A.
A? Okay. Yeah, that was one you tried for homework, wasn't it?
Yeah.
Yeah. Okay, so page 32, question 2A. What is the coefficient of x in x minus 1 squared? Okay. Right. Now, Siva, would you have any ideas on what to do first?
Haven't gotten here yet.
Oh, you're not in this lesson yet in your math class. What page are you on actually?
The one before Pascal's right.
Okay, then I won't pick on you for this question then. So, Abir, would you... No, you were the one who asked me this, so perhaps I should ask Alfreda or Anna. Do one of you know what to do first? No can be an answer if it's no, that's okay.
No.
Okay, fine, yeah.
Probably no.
Alfreda? Also a no? Yeah. Any ideas?
Oh. I remember. Yeah. We will.
Yeah.
The seal.
The C is correct, yeah.
2 seals. I guess 2.
1 C.
1 seal.
Yeah.
And then.
Bracket and bracket. Not quite, yeah.
I'm not quite sure. Oh yeah. And then we'll divide the x and minus 1 in each bracket.
X and minus 1 in each
Yeah.
bracket. Yep,
So
good.
the squared will go to the x.
Yeah, now explain why you're putting the square on the X.
It always goes to the first bracket.
Yeah, but why the number 2?
Because the bracket it's squared.
So, because of this.
Yeah.
Nice try, but not quite. Not quite. Does anyone else have an idea on what number goes here?
No.
I think you might know, Amna. I think when I show you, you'll figure out. I should put a 1 here, because I was looking for the coefficient of x. So I want an x1.
So
Now the 2 goes here. Yeah?
Yeah, I started to remember that.
It's coming back to you now, is it? Okay. What number goes... Oh, sorry, go ahead, Abir. Yeah.
So if it's coefficient of x squared, the one on the first bracket will be 2.
Yeah.
Okay.
Yeah, and if it was x cubed, it'll be 3.
Okay.
Yeah. So this one here is because it's what I want. Alright? This 2 here, this one is because of this power here. Now, what number do I put down here? Not 0.
The same number of the x power, the power of
Yeah, that's it. So that's 1 there.
x.
And finally, what number goes here?
1.
Why?
Because the sum of the two brackets has to be the answer of the c power.
Yeah, those two have to add to make that guy.
So that you get the 2.
Yeah, that's it. So 2c1 is a 2, x power 1 is an x, and minus 1 power 1 is a minus 1.
So you did minus 1 into the power of x? Why did you get 1?
Oh, this
Oh,
one? Yeah, this one here. Yeah. The other thing is, these powers always add up to make what this power is.
Okay.
So if this was a 9 and this was a 10, then that guy would have to be a 1. Yeah. Yeah. This is called the binomial theorem. Binomial theorem is the rule I'm using here. Yeah, binomial theorem. So this becomes minus 2x. So the answer is minus 2, because the word coefficient means the number in front of the x. So this is the answer, is minus 2. So Siva, you haven't seen this stuff yet. You did Pascal's triangle last time, yeah. It's a bit tricky, isn't it? But
This question, I don't think that's tricky. You have to.
well, now it's not
memorize.
tricky.
No, the thing is, you have to memorize the steps, and then everything will be fine. That's it.
Yeah. Once you remember how to fill in the numbers, yeah. When you're ready, what will we have a look at next? Well, let's see what each one of you thinks first. So, what were you saying, Amna, first?
Page 28, the question, it's like x.
Which question?
No, I'm talking in general.
Oh, okay.
Yeah, we have like two types or several types of questions.
Yeah.
Like the integers, I just wanted to know when I get the answer, how can I know like the difference between the ZR and 0?
Yeah, so your question really is, what do you do if it's an N, an OR,
Yes.
a Z? Yeah. And what was your question you were going to look at up there?
32.5. The final feature.
No, definitely not on the exam. Definitely not. Way too hard. The question 5 I just put in there for, I don't know why. It's way too hard. Okay, so we'll have a look. Well, we'll talk a little bit about page 28. Amna was wanting to know what. So firstly, Amna, actually to start with, do you know what the difference is between N, Z, and OR?
Yeah, the integer numbers, the natural, yeah.
Okay, so describe to me what this is. Tell me what this means, if you know.
It is 1 and 10
Yeah.
numbers.
Yeah.
So we have only we have two numbers only.
Ah, no.
No?
You are thinking of this.
Oh yeah, I guess.
Yes. So it's not that. Siva, have you seen this in your math class? Do you know what this means?
Everything from 1 to 10, including 1 to 10.
Yeah, it's everything from 1 to 10, including 1 and 10. Now, Amna, I really want to stress the word everything. So when Siva was saying everything from 1 to 10, it really means every number. So for example,
1, 2, 3, 10, 10.
yeah, but also something like 2.1,
Yeah.
2.99, these numbers as well. So if I was to say X lives in here, and I was also to say X is an integer, then how do I combine these? Because these aren't quite the same thing. Because this thing here says X is everything from 1 to 10, including 1.5, 1.6, something like this. But what does this mean? If I said X is an integer, what does that mean? Like what type of number? Give me an example. What's an integer number?
The
1, 2, 3, yeah.
Negatives
or
including the natural numbers.
yeah, negative, positive, natural numbers. So the only way I can mix these two together is if x was number 1, 2, 3, 10. These are between 1 and 10, true, including 1 and 10, and they're integers. So I need to combine these two to make this as my final answer. It's wrong to write this as the answer if I need this as well. Yeah.
No.
So it's kind of it's a little bit tricky, but you know, if you suppose I had something like, what about if I had something like this, 0 to 3, and I write this here? What does that mean, Anna? Do you know? Or do you think you know, Alfredo? What is it? Excluding 3. So give me some numbers that is in this. 0, 1, 2. What else? Oh no, there's more. 0.1, 0.2, 2.9,
Yeah.
2.99, yeah, 2.999,
No.
yeah, 3,
No.
no. But if I said x is a natural number not including 0, then what values of x is possible? If it has to be here and it has to be natural and not 0, 1 it has 1, yeah, what else? 2. Anything else? Could it be 3? Why not? It's excluded from the first one.
Oh yeah.
So only 1 and 2. Yeah, is it a little bit clearer? Yeah. Okay, good. What will we have a look at next now? What about you, Siva? Yeah, go ahead.
The general formulas.
Yep, sure. Which page is that?
It's 34.
Have you done page 34? No, you haven't, Siva. No, you're not on 34. You're at 30. Okay. Right. Now, just before I do that, I just want to check in. Do you need anything cleared up from?
So far, no.
No. Okay. So you're getting to see a little bit of what's coming up next then. What question on page 34?
First one.
Number 1?
Yeah. K.
1k. All right. 1k. All right. So, Siva, in this one here, you just need to try and figure out what number comes next. 1, 2, 6, 24, 120, 720, and what comes next? Yeah, good. So, see if you can figure out some rule there. What are we thinking? I'll give you some tips. Okay. Would you say these numbers are increasing fast or slow? Fast. So usually when that happens, it means there's some kind of multiplication. It's a multiplication rule. So let's look at what multiplication is happening. So here, what did I multiply 1 by to get a 2? 2. And what did I multiply 2 by to get a 6? 3. And 6 to make a 24? I think we see a pattern now, don't we? So 24 times 5 is 120. 120 times 6 is 720. So the next value will be 720. So that would be 50,000 and something. What is it? 50,040 is the next number then. Yeah. See, it's clear when you see it now. You know, it's like this sequence. Remember we did this one in class? Yeah. I've asked the teachers this one, and then none of them got it.
And what is the difference between periodic, divergent, and convergent?
Yeah. So convergent would be something like this: 1, 1.5, 1.75.
So decimal number.
Not necessarily decimal, but usually decimal. It looks like a number that's moving to something. In this case, we say
They are getting closer to 2.
yeah, that's it. Yeah, so that's convergent.
Yeah.
Okay. Divergent would be the opposite. Divergent means the opposite of convergent. So that would be like 1, 2, 4, 8, 16, 32, 64. that one is divergent, because it's just getting bigger and bigger.
Oh.
Yeah? Problem?
This is divergent, okay.
The other one's getting bigger too.
Yeah, but it doesn't go
It's
past
like
2.
decimal. It's
Yeah.
like decimal and like
It's approaching 2. It's trying to get to 2. Yeah, yeah. Yeah, no, I get what you're saying. They're both getting bigger, but you can appreciate that the second one is radically different to the first. You know?
And the periodic.
Yeah, well, let's see if anyone here knows the periodic sequence. Someone give me an example of the periodic.
I guess that you explained just today. I guess it's like the -1, 1, 1, and then like again -1, 1.
Yeah, it's a repeating thing. Yeah, so you could have something like 1, 2, 3, 1, 2, 3, 1, 2, 3.
Yeah, okay.
That one is called a periodic function. Yeah. Now, just so you know, Anna, from a technical language point of view, something which is periodic, we actually can say it's also divergent. Because technically, divergent is the opposite of convergent. So if it's not convergent, it's divergent. So periodic, is this convergent? Is not convergent.
It is like
So we can also say it's divergent then, yeah. Okay.
3G.
On which one?
Same page.
Yeah. 3G.
the same
Okay.
page.
Yeah. Yeah. Now, I know you haven't done this, Siba, but I wonder now if you have an idea, if you've seen it before. Here I say, what do I say? Find W4, and I give you the formula Wn equals 4 times 7 power n. So I want to know what is the fourth term, and I give you this formula. So any ideas on how I'd get this? Siba, just wondering. Because I know you haven't seen it yet, but I just wondered if you've seen it before.
I haven't taken it before.
Oh, you haven't? Okay. So this is completely new then for you. Abir, you were going to say?
Is it just 4? Did you?
Yeah, you sub in 4, yeah. So you put in 4 and you get 4, 7 power 4. That's it.
Oh.
Yeah. You thought there was more to it? No, that's it.
Me too. I thought
Yeah, no, that's it. You were thinking perhaps just put in the 4, yeah, that's it. I'm looking for the fourth term in the formula. Yeah. Okay, good stuff. What's next now? What else do we need to see? How are we doing for time? Oh yeah, there's lots of time left. No, it can be something further back. It doesn't have to be recent.
Can we do 34/6?
We're sticking recent. 34/6. I'm actually going to do that one, I'd say, in the tutorial, because the reason for that is I like to use Excel to do this question, because Excel, you can graph, and I usually use Excel to graph this one, because it's, yeah.
Yeah, no. Tell us the question. The question is about. This is the question. And you just have to place the.
Siba, any questions? Or are you happy in maths class? There's no problems. Yeah?
I have a question.
Yeah.
About drawing sketching the quadratic graph.
Yeah.
When can I know that I have to shape the lower
Oh, yeah, okay, yeah.
scale?
When the shape the top
Yeah.
or the bottom though, yeah. So if you have your quadratic and you have something like this, and you want, and let's just pretend the quadratic. I'll make up a quadratic. I'll say it's x squared minus 3x plus 2. So Amna wants to know, when do you shade in this part and when do you shade in this part? So who knows that for her? Does anyone know this one? When do I do which one? So let's start with when would I shade in this? When everything between is? Yes, I'm not being very clear, I'm sorry. What I mean is there's a symbol here, and it's either going to be greater than or less than. And one of them matches up with shading underneath.
Yeah.
Yes, which one?
I guess that I
Greater
understand it. Maybe when this minus 3x plus 2 is equal, it's bigger or less than, depends on the sign we have. The other side? Yeah.
This sign? Here?
No.
Oh, here, the numbers.
Yes.
Ah, no, it has nothing to do with those numbers.
No?
Anyone else? This? Or this? Oh, sorry, or this? Oh, interesting, nobody knows?
Greater than?
We're thinking greater than, is it? You're thinking that as well? You're thinking that as well?
How do we figure out greater than?
Well, they think it's greater than.
I just know when there are 2 points.
Yeah. Ah, you might be thinking of discriminant.
What are you talking about?
This thing. Are you thinking of this guy?
Yeah.
Yes.
Oh.
Yes, when there's 2 points, what are we saying? This guy is positive. Yes.
That's what I meant.
That's what I understand now. Good. Not that. Yeah. And you were thinking greater than as well, for the same reason? Or just a wild guess?
I guess.
Well, you have a 50-50 chance of being right if you're guessing, you know?
Then you have to shade the outer part.
Yeah, that's it. So look, let me explain, okay? Describe positive or negative. Would you say this red region, do you describe it as a positive or a negative region? Negative. Now, why? This is correct. This is a negative region. Why?
Because we're shading the lower part.
Yeah, because it's under the x-axis. It's down here in the negative y. Okay, good, it's negative. Now think, if a number is negative, is it bigger or smaller than 0?
Smaller than 0.
Now you see, the way your expression seems like I said something ridiculous, you know, or like, of course it's smaller. You're absolutely right. So, it's less than.
Yeah.
Yeah, okay. But you were asking me this question. You seem confident.
They say like it is greater than, but I thought it's less than. I was thinking for a reason.
Okay. All right. You want to be justified. You want to know why. Yes, okay. And likewise, you were saying up here, this is a positive region, so it would need to be greater than 0 then. Yeah. Okay. Questions, Eva? Yeah.
Yeah, I don't get what's meant by this, because usually when I get my points and I draw the graph, I know, like if it's like for example 1 and 7 and both 1 and 7 are included, then I hate with. I don't get this point.
Yeah, now you see, I don't know which way Joan showed you to do these problems. Like for example, actually, you know what? Maybe we'll just do this question as an example. So, let's take this one here. X squared minus 3x plus 2 greater than 0. What would we do first here? What's the first thing to do for this? You've done these types of problems. What page is this on? What page is this on? This is from the lesson on page...
Then I'll take the factors.
The factors, yeah, good.
So it will be x1 and x. Which page is it?
I don't know which page this is, sorry. It's like what's on inequalities. What page is inequalities?
Inequalities are 28.
28, yeah. It's like this. It's just my own example. Sorry, Steve, what were you saying? You factorize first, isn't it?
Yeah.
Which is a 1 and a 2. Yeah. Okay, now what?
I'll do the quadratic equation and get the solution.
Yeah, so that's 1 and 2.
Yeah.
But what next? So it's not quite x equals 1 or x equals 2 because you have this guy. So the real question now is, what do you do next with your 1 and with your 2? Now the way we,
Then I like.
Oh, let me see. Yeah. Come around, I'm tired. Whoop.
Usually do
Yeah. So the question then is, how do you know it's like this, or how do you know it's like this? You see the way here you say x is between 5 and 8, whereas here you say x is less than 3 or more than 7. How do you know which way to write the answer? Is it like this way, or is it like this way?
I don't know, from the example she gave us, all of them I did it this way.
Oh yeah, so like here this is one bracket, but this one here is two brackets. This one here is two brackets, this one here is one bracket.
Wait, let me think about it.
Go think about it, yeah. Yeah.
Okay, substitute it and then see if it's greater than.
Ah, this method, yeah. Indian British method. No, I've seen this one before. I don't like this method. But you can do it this way if you really want to. You substitute it in to see which it is, yeah. I really like doing it this way.
Yeah, we only made the two brackets in one question.
Ah, yes, okay, so maybe
So
this...
the how I solved it was all in this way, no brackets.
Yeah, okay, fair enough. So maybe it wasn't made clear. You actually have to decide which way to write the answer, and the decision you make depends on what this fella is. So, the way we think about it, at least when we were doing it in class, is you make a very quick sketch. So where are the roots here? 1 and a 2. And you draw a very quick quadratic. And then you say, when is this quadratic positive? Here is positive, and here is positive. So this is when you use the two brackets. So that's when you would give the answer like this, minus infinity to 1, and 2 to infinity then. Now, Siba, if it was the other way around, if it was less than or equal to 0, that is equal to this region, and that's when you would use one bracket, which you would write like this, 1 to 2. So the choice you make between that answer and that answer depends entirely on what's happening here, and you can use a graph to figure it out.
Yeah,
If it's 2, yeah.
I did it, but on my own I did it, but I didn't shade it because I didn't know that we had to do that.
Yeah, that's a step you need to do. So if there's two shaded regions here, you need two brackets. And if there's one shaded region, you need one bracket. Yeah? It's okay? You want it to be harder? Yeah, that's it. Yeah. These are okay questions.
Yeah.
They're not so bad. Yeah, what will we have a look at next now? No. We are geniuses?
Genius.
Not yet. So, you are happy with all the questions so far? Like if I was to pick any question, you could do it? Because, you know, the mid-semester exam, I'm going to give you 20 questions. 20?
Yeah.
How long?
Yeah, let's see. 90 minutes. Don't worry.
I don't know, I have those around, use everything.
Let me see. So this is that for this one here. So that's less than. So less than means under. So this is under and this is under. Yeah, so you need 2. Yeah. What's wrong? 20 questions in 90 minutes. Yeah. No.
We just have to use to practice more, then we can solve it better.
Yeah. Oh, okay, I'll tell you, I'll give it 100 minutes then. Because 100 minutes give you 5 minutes a question. You don't need... Would this take more than 5 minutes? This one?
Not this question, maybe...
Yeah. So some questions take more, some take less. Average 5 minutes. Look, like one of the questions I put in the quiz is I've given you a Pascal's triangle and I deleted one of the numbers. You have to tell me what the missing number is. How long will that take to do? 5 seconds?
Yeah.
Yeah, so, you know, you'll be fine. You'll be fine.
Big number.
And it wasn't even that big. It was maybe on the 5th row or something, but, you know. Well, I gave you the whole triangle and just deleted one of the numbers from the picture. So there's obviously easy and hard questions, obviously. Anyways, you'll have a different test. I don't know what Joan's doing for you. She might not. She might give you a 1 hour test. I don't know.
What are you giving?
1.5 hours.
Think you have more time?
I think.
Or that means more questions?
No, there was more questions. No.
20 questions.
Yeah, I think okay, I guess that's fine.
You know, make you work a little bit. It's good for you. Yeah? Okay, what else do we need to see? How are we doing for time? Well, I suppose that there's nothing really. If there's no other question. No? No? Okay. The maths test since we're talking about it is on the
2nd of October.
How far away is that now? Yeah, I think yours is on the same day. 22nd. Yeah. Yeah, yours is on the same day, I think. 22nd. The maths mid-semester exam.
You posted that on Moodle.
Yeah. The 22nd means we will have 2 more Fridays, okay?
2 weeks,
Yeah, 2 more Fridays. So my mid-semester exam is only going to go up to page.
Just don't make it like so hard.
Page 42. That's only a couple of extra pages.
Limits. Oh, limits.
What?
I just now remember the class last year about limits.
You liked it?
Yeah. It's not that hard.
It's not too bad. So look, your mid-semester test in 2 weeks is only up to page 42, which we're not far away from. So it means that next Friday we would have done everything that would be on the mid-semester. So you really want to make sure for the next 2 Fridays you can do everything from up to page 42 for sure for your test.
Okay.
I think Joan sometimes, I think her exam might be a little bit more. I think she was talking about putting stuff in from the next chapter as well, the exponentials and the logs. She hasn't decided yet. She was only thinking about it when I was talking to her. So.
Convince her not to.
Yeah, perhaps I could try. Okay. All right. So we'll continue next week then. If you want to prepare for the mid-semester, I'm only going to make the questions like the questions in the book.
Yeah.
It's going to be 20 sort of book questions. You know, like something like this. You know.
Only one question.
Like if you, like questions in the book, I'll just change the numbers.
The questions will be taken from the.
I'll change the numbers, but it'll be the same. It'll be the same type of questions. Yeah.
That's what all teachers say until they open the exam.
Not the same.
Well, if it's not exactly like that, it's like for example, the Pascal's triangle question, where I deleted one of the numbers.
That's not.
Yeah, so that's fine. Yeah. All right, we'll wrap it up there. So.